Hello, this is Mr. Stansbury. I'm going to take you through the 14 H notes on tree diagrams. All right. At the end of this, you should be able to say, I can use tree diagrams to find the probability of compound events. All right. So let's start off. Example 13 from page 474. Excuse me. A box of chocolates contains equal number of milk and dark chocolates. It has 15 hard-centered milk chocolates, 5 soft-centered milk chocolates, 10 hard-centered dark chocolates, and 10 soft-centered dark chocolates. So, first thing it wants us to do, copy and complete the diagram for randomly selecting a chocolate from a full box. All right? So, basically what you want to do here is you want to figure out the probability of getting a milk chocolate versus a dark chocolate. Right? So, it has equal number of milk and dark chocolates. So, probability of drawing a milk chocolate to a dark chocolate is 1/2. So you can either leave it as a fraction or you can put it as a decimal. I'm going to write it as a decimal because I like multiplying decimals better than fractions. So 1/2 chance of getting milk chocolate and 1/2 chance of getting dark chocolate. All right. So of the milk chocolates, how many of those are hard chocolates and how many of them, how many of them are hard centered and soft centered? So 15, excuse me, are hard centered and 5 are soft centered. So that really is 15, there's 20 total, 15 out of 20, which is, 3/4, which is 0.75. So I'm going to try that, 0.75. So then that leaves the other quarter, 0.25 for soft-centered, so 0.25. Okay. And then for the dark chocolates, 10 are hard-centered and 10 are soft-centered, so that's also 50%, so 0.5, 0.5. So we have now completed the diagram from randomly selecting chocolate from a full box. Okay, and that's actually going to help us figure out part B. What's the probability of getting a soft-centered dark chocolate? So soft-centered milk chocolate, soft-centered dark chocolate. It's this one here. So to figure that out, it is simply going to be, we're just going to take this path here, dark, soft. So we're going to take this. That's a bad color. Let's try that again. Let's try something you can see a little bit better. This is the path we want to take. So really it's 0.5 times 0.5, which gives us 0.25. So 1 in 4 chance of randomly selecting a soft-centered dark chocolate. All right. Now, let's see, same thing now, except for now it's a hard-centered dark chocolate. All right, so hard-centered dark chocolate is going to be, sorry, it's not even dark chocolate, it's just a hard-centered chocolate. So here is one way of getting a hard-centered chocolate, and here's another way of getting a hard-centered chocolate. So we got to take these two here and add them together. So let's do the hard-centered milk chocolate. So that is 0.5 times 0.75. And then we also have the hard-centered dark chocolate. So that's going to be 0.5 times 0.5. All right. So 0.5 times 0.75 is going to give us 0.375. And this again is 0.25. So then we're going to add those two probabilities together because it's just a hard centered. So we can get either or. Or basically means add and means multiply. So this is or. So we do 0.375 plus 0.25. Which gives us 0.625. That is a 0, or supposed to be. Not a Q, but a 0. All right. So that's the probability on that one. All right. Okay, let's take a look at another example here. Carl's not having much luck lately. His mighty motorized big wheel will only start 80% of the time, and his grass guzzler will only start 60% of the time. Draw a tree diagram to illustrate this situation. All right. So, kind of like what we had on the last one, except for it doesn't even start anything for us. We just got to draw it ourselves. All right. So, start with a tree. And again, you can go vertical tree or horizontal tree. It doesn't matter. All right. So, let's take this here to be the big wheel. So we'll do that for B, and then this will be the grass guzzler. Okay. So we'll start 80% of the time. All right. So let's do that one. Okay, we're not going to undo that. We're going to do this here. There we go. This is going to be the big wheel starts and doesn't start. There we go. All right, so the probability that the big wheel starts is 80%, so 0.8, and then the probability that it doesn't start is 0.2. Okay. Now, these are independent events, so now we'll go to the next one, which is now the grass guzzler. So this is the probability that it starts, doesn't start, starts, doesn't start. Okay? So again, they're independent. So the grass guzzler starts 60% of the time, so that's 0.6, and doesn't start is 0.4. And same thing for this here, 0.6, 0.4. So here is our tree diagram that now illustrates this situation. Okay, so use the tree diagram to determine the chance that both will start. So start and start, that's going to be this here. It's going to be 0.8 times 0.6. Okay, and if you multiply those together, you get 0.48, or 48% of the time. All right. Okay, so now let's see, we'll do Carl has no choice but to use his big wheel, so that means the big wheel starts, and the gas guzzler, that's a G here, does not start. Okay, so starts and then doesn't start, so that's going to simply be 0.8 for the big wheel starting, and then times 0.4 for the gas guzzler not starting. So that's going to give us 0.32, or 32%. All right. All right. Let's, before we hit the next one, let's take a little video break, won't we? This one's on cats. That's a little scary. All right. So, little funny excerpt from cats. All right, last one. Example 15, page 476. Johnny ate 3 spoons, 2 forks, while Bobby ate 1 spoon and 4 forks. One of the 2 boys is randomly selected by tossing a coin, and 1 utensil is removed. Determine the probability that it's a fork. Okay. So, a couple different ways we can look at this here. Let's just let's take each kid here and kind of use them as a little, here's their forks and spoons. Okay, so let's call this one Johnny. So he has 3 spoons and 2 forks. And then the other one is Bobby, and he's got 1 spoon and 4 forks. Okay, so determine the probability, one of the 2 boys is randomly selected by tossing coin, and then 1 utensil is removed. Determine the probability that it's a fork. Okay, so again, each one of these is a 50-50 chance. So let's do this. How about let's do probability that a fork is removed from Johnny. So let's see. The probability of Johnny being chosen is 0.5, and then a fork is, let's see, that is 2 out of 5. So how about this? Let's do this back to fraction. This might be a little easier. So 1/2 times 2/5. Okay. And then we are going to take that and we're going to add the probability that it's Bobby instead. So Bobby again is 1/2 chance of Bobby getting chosen. And then forks, he is got 4/5 of the utensils in his stomach are forks. So we're just going to add those two together. So that gives us what? 2/10 plus 4/10 gives us 6/10 or 60% chance. Okay. That's really all there is for this. If you have any questions, please ask. But now you should be able to say that you can use tree diagrams to find the probability of compound events. All right. Thanks.